Hello everyone, in this video we'll be looking at section 8.3, which is trigonometric integrals. So these are integrals that involve trig functions like sine, cosine, tangent, and so on. Okay, so subsection 1 here, integrals involving powers of sine and cosine. So here we're going to look at techniques for studying integrals of the form sine to some power times cosine to some power. And so to try to find the antiderivatives of functions of this form, we need to break them into combinations of trig integrals so that we can apply the power rule, right? So in other words, we can apply use substitution. So it looks like sine to some power and then cosine on the outside. Since cosine's the derivative of sine, we could do the power rule with the use substitution. And so that's kind of our game plan here. So to do that, we're going to keep in mind these three identities, right? The first one is the Pythagorean identity, and the other two and three are the power reducing formulas. So notice 2 makes a sine squared to a cosine to the first power, and 3 makes a cosine squared to a cosine to the first power. And that's helpful because we know how to integrate sine and cosine to the first power. Okay. So guidelines for evaluating integrals involving powers of sine and cosine. So we have some steps that we follow. So when the power of sine is odd and positive, here's what we do. We save one factor of sine and convert the other factors to cosines. Why? Because if we save that one factor of sine, then and convert everything else to cosine through our trig identities, then we can do a use substitution with cosine, and that sine hanging on the outside will be the derivative that's on the outside for use substitution. When the power of cosine is odd and positive, we do the exact same thing except with leaving one cosine on the outside. So that way we're able to do use substitution. And then step 3, when the powers of both sine and cosine are even and non-negative, what do? We make repeated use of formulas 2 and 3 to convert the integrand to odd powers of cosine, right? So we replace sine squared with the cosine to the first power there in rule 2, and we replace cosine squared with cosine to the first power until we get to an odd power of cosine, and then we proceed as guideline number 2 once cosine is odd. Okay, so that's a lot kind of thrown at you in words, so let's look at some examples. So this first example, it's sine cubed times cosine to the 4th. We notice that sine is odd and positive, so we're going with the first guideline there. And so in the first guideline there, it says to save one factor of sine, right? So what I'm going to do here is, sorry, I'm pulling this up in my book. I'm going to rewrite this as sine squared x cosine to the 4th x times sine x dx. So I broke up that sine cubed into a sine squared and a sine. And now what I'm going to do is take this sine squared and get rid of it, make it a cosine. And the way I'm going to do that here is that sine squared x is equal to 1 minus cosine squared x. So I'm going to write this as the integral of 1 minus cosine squared x times cosine x, cosine to the 4th x times sine x dx. Okay, so I have 1 minus cosine squared x, that quantity multiplied times the single item cosine to the 4th x times sine x, so I can distribute that to both terms. All right, so I'm going to write this as cosine to the 4th x sine x dx, well, not the dx, we'll save that for the next step, minus cosine to the 6th x sine x dx, right? This is all dx. Now I'm going to use rules of integrals, and I can distribute that integral sign, so it's two different integrals. So this is cosine to the 4th x sine x dx minus the integral of cosine to the 6th x sine x dx, right? And notice that each one of these integrals individually I can solve with a u sub with u equals to, cosine x, right? This again is a u sub with u equals to cosine x. And so if I do those u substitutions, notice it's just a power that I'm left with, right? A power function. So I'll do those separately here. So for integral number 1, I'm looking at cosine to the 4th x times sine x dx. And so I'm going to do the u substitution the long way, and then I'll kind of show you why you can shortcut it, especially with these trig identities, right? And if you're not comfortable with the little shortcut we talk about, then feel free to just do the u substitution as usual. So u equals to cosine x du over dx equals to sine, the derivative of cosine is negative sine x. So that means that du is equal to, or I'm sorry, dx, hope if I did it right, dx is equal to du over negative sine x. So when I go to do my substitution, I write u to the 4th because cosine is u, and I'm taking cosine to the 4th is taking cosine to the 4th power. And then I have sine x, and then dx now is du over negative sine x. Right, so this ends up looking like minus the integral of u to the 4th du. Right, so this is what I was saying, it becomes a power function, right, which we can integrate. So this is negative 1/5 u to the 5th plus c. Negative 1/5, what is u? U was cosine of x, so this is cosine to the 5th x plus c. The second integral, we're going to integrate cosine to the 6x sine x dx. So again, u is equal to cosine of x. So du over dx is equal to cosine x, which means that dx is equal to du over cosine x. So now we're going to substitute. So I get u to the 6th times sine x du over, the derivative of cosine is negative sine. Try that again. Negative sine x here. So again, I get negative the integral of u to the 6th du, which is a power function. We know how to integrate, so this becomes negative 1/7 u to the 7th plus c. Substituting our u back in, I get cosine to the 7th x plus c. Okay, so now what I'm going to do is talk about the kind of shortcut way of looking at u substitution here. So notice that when I look back at this original integral here for the first integral, right, this guy right here, I see that cosine is the inside function and its derivative is negative sine, which is almost perfectly on the outside, right? And so what I can do here, going back down, I get that, okay, well, I've got my inside function is cosine with its derivative perfectly on the outside is sine x without the negative sign. So I make that negative sign there, right? And then I say, okay, if cosine was the inside function, I know that when I do this substitution, really I'm just leaving the inside function alone and taking the antiderivative of the outside function, right? So the antiderivative of the outside function, which is something to the 4th, is 1/5 times whatever that something is. In this case, it's cosine to the 5th power x. And then I don't have to chain anything on, because remember this, we're really undoing the differentiation rule, chain rule. And so that would be chaining on the derivative. But here we don't do that because we're doing the opposite. All right, so I can very quickly get that 1/5 cosine of the fifth x by just thinking about undoing the chain rule, right? So if you're able to jump from and follow my arrow there, go ahead. If you're not, go ahead and write out those two integrals and do the substitution. But from now on, especially with these trig integrals, I'm going to go ahead and do the kind of quick way and jump from the last equal sign all the way down to the arrow to where I'm writing now. Right? So one thing to be careful of here is that minus sign, right? So this is minus negative 1/7. So I'll go ahead and just be careful. Cosine 7x, and then we plus c. All right, so my final answer is 1/5 cosine to the fifth x plus 1/7 cosine to the 7x plus c. Okay, so, and then in this next example, the power of cosine is odd and positive, and it's a definite integral. So first we'll find the antiderivative, and then we'll plug in our limits. All right, so since the power of cosine is odd and positive, what I want to do is save one cosine factor. All right, so again, I'm just going to do the antiderivative first with no limits. So this looks like cosine, and I'm going to save one cosine factor. So I'm going to write this as cosine squared x over the square root of sine x, and then save that other factor of cosine right there, and then dx. So now I'm going to replace that cosine with sine, right? And so cosine squared x is equal to 1 minus sine squared x by that rule, the trig identity, right? So I am going to rewrite cosine squared x as 1 minus sine squared x over the square root of sine x times cosine x dx. So then I end up getting 1 over the square root of sine x. And I'm going to go ahead, well, we'll leave it as this. So minus sine squared x over the square root of sine x times cosine x dx. Now when I do this next line, I'm going to simultaneously distribute, here I guess I should explain what I just did, right? I just split up the numerator into two different terms, right? Remember that was one of our rules that we learned last section, where I can say, okay, that's really the 1 over the square root of sine times minus the sine squared over the square root of sine. Right? So now in this next step, I'm going to distribute the negative, or I'm going to distribute the integral sign as well as the cosine x dx in one step. So that way I don't have to write it twice. Right? So this looks like the integral of 1 over the square root of sine dx, times cosine dx minus the square root of sine squared over the square root of sine, right? So that would be sine squared x over sine to the 1/2, sine x to the 1/2, right? That's equal to 2 minus 1/2, which is 3/2. Right? So this ends up being sine of x to the 3/2 power. Right? So that's what I'm going to write here. Sine of x to the 3/2 power. Cosine x dx. Right? So I distributed the sine x, and I distributed the cosine of dx, and I distributed the integral sign. And I'm actually even going to do better here. Instead of writing that as 1 over the square root, 1 over the square root is negative 1/2, right? So this is sine x to the negative 1/2 power. The only reason I'm doing this now is writing that in that way is because now it's very apparent that I'm going to do a u sub with u equals to sine x in both of these. So again, if you're not comfortable with me jumping the step, you can go ahead and practice and do the u substitution. But notice here that I have cosine on the outside, which is the derivative, the derivative of sine, right? And so I am able to do just the power rule with the inside function being cosine and the outside function being, in this case, u to the negative 1/2 and the other integral u to the 3/2, right? So if I were going to take the antiderivative of something to the negative 1/2 power, I would bump up the power by 1. So negative 1/2 plus 1 equals to positive 1/2. But when I divide, that means multiplying it by 2. And then I leave the inside of function alone, and then I bring it to that new power, which we said was 1/2. And since the derivative was exactly cosine x on the outside, that's all I have. And then minus, so now sine is on the inside, so it's u to the 3/2 is my power function. So 3/2 plus 1 is 5/2, but I divide by that on the outside, so I say 2/5. And then I leave the inside function alone, sine x, and then I take it to the new 5/2 power. And again, since the derivative is exactly cosine x on the outside, when I undo it here with the u substitution, when I undo that chain rule of differentiation, that's all I have left. All right, so this is what I get. Now, remember, so this is my antiderivative, but I was trying to find the definite integral, right? So now we need to find the definite integral, which is the integral from pi over 6 to pi over 3 of this original function cosine squared over the square root of sine x dx. So we know this is equal to the antiderivative, which is 2 times sine to the 1/2. Sine to the 1/2 is the square root, right? So the square root of sine x minus 2/5 sine x to the 5/2, and we're going to evaluate that from pi over 6 to pi over 3. All right, so 2, and then I take sine at pi over 3. Sine at pi over 3 is radical 3 over 2 minus 2/5. Sine again at pi over 3 is going to be radical 3 over 2. And then subtract 2 times the square root of sine at pi over 6. Sine at pi over 6 is 1/2 underneath the square root. And minus 2/5, and now we get 1/2 to the 5/2 power. Right? So that's my final answer here. 2, so we can simplify it a little bit. This looks like radical 3 minus radical 3 over 5 minus, here I would get 2 over radical 2, which is equal to just plain old radical 2, and then plus 2/5 times 1/2 to the 5/2 power. Right, so that's my final answer. It really doesn't get much prettier. You could do 1/2 to the 5/2 power, but if you did that, you'd end up getting oh shoot, this was supposed to be to the 5/2. So really I didn't get any prettier. So we'll just go back up to this last line here. We'll leave this as our final answer. And that's approximately equal to 0.239. Okay, So one more for this section here, or this subsection. How about if the cosine is even and non-negative, and here there's no signs, right? So in this case, I'm going to, it would be like case number 3 here. And what does it say to do in case number 3? It says here the cosine is even and then there's no sign. So I use that identity number 3. That cosine squared x is equal to 1 plus cosine of 2x over 2. All right, so here I'm going to rewrite this as cosine squared x squared dx. Right, because cosine of the fourth can be written as cosine squared squared. And then now I'm going to replace cosine squared with that identity, 1 plus cosine of 2x over 2 squared dx. And I actually like to rewrite this. You don't have to do this step, but I like to write this as 1/2 plus 1/2 cosine of 2x, just because it's makes it a little bit easier here to expand when we go to square this. Right? So again, to square this, you can multiply out this binomial, but I like to do it the quick way, right? The first term squared times 2 times the first times the last term, and then the last term squared. So the first term squared is 1/4. 2 times the first times the last is 1/2 cosine of 2x. The last one squared is plus 1/4 cosine squared of 2x. And then all of that with dx. Okay, so notice here I've got a cosine squared x, right? Once again, I'm going to use that formula, the reduction formula. And again, the reduction formula says that if I have cosine squared of something, then it's equal to 1 plus cosine of 2 times whatever that something is over 2, right? So here I get 1/4 plus 1 over 2 cosine of 2x plus 1/4. Now I get 1 plus, and instead of writing cosine of 2x, I need to be careful here, because what is inside my function when I square it? 2x is inside my function. So I need 2 times 2x, or 4x, to be inside my function in this case. And now over 2 dx. So simplifying this here, I get 1/4 plus 1/2 cosine of 2x plus, remember this here is 1/2 plus 1/2 cosine of 4x, right? So I get plus, move this down a little bit. 1/4 times 1/2 is 1/8 plus 1/8 cosine of 4x dx. I'm going to combine my like terms here. So the 1/8 and the 1/4, 1/8 plus 1/4 is going to give me 3/8. And then I'll write that with its own dx, since I'm going to do these separately. Well, I don't even have to do that really. So instead of writing the dx, I can just write this is the integral of 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x dx. And now I can individually take these antiderivatives, right? So here I get 3/8 x plus, remember, how does this work? The 1/2 hangs out for the ride. And remember, if I were to take the derivative of cosine of 2x, I'd need to do the chain rule and chain on 2x. So to undo that to the antiderivative, I need to chain on the opposite of multiplying by 2. So I divide by 2. And then the antiderivative of cosine is positive sine x. And I should leave the inside alone, right? So this is 2x should go inside of there. And then plus 1/8, And now same thing. The antiderivative means we have 1 over whatever the derivative of the inside of the function is. The antiderivative of cosine is sine, and we leave that 4x alone, plus c. And again, if you're uncomfortable with that quick way to do it, you can do a u sub with u equals to 2x, and here you could do a u sub with u equals to 4x. But I highly suggest you get comfortable with doing it the quick way so you can save yourself some time. So my final answer here is 3/8 x plus 1/4 sine of 2x plus 1 over 32 sine of 4x plus c. All right, so that's the end of this video. We'll pick up with subsection 2 of 8.3 in the next video.